And we'll talk about doing our duty today with these lab scope disasters, avoiding them. Two things, like I mentioned, we're going to drill down. There's not really much of a PowerPoint other than just, my contact info. I'll show you at the end how to get a hold of me if you got a question or a comment, complaint, or just curious about something. I'll give you my cell phone number. Please text it first, because I don't answer a lot of calls. My phone number gets, I think, sold on mailing lists. I get all kinds of weird stuff going on, and same with texting. But if you text me a message and you say, "Hey, I'm a technician, and I was, in a training class or on a webinar with you or one of your Delphi compadres," I know Jim Wilson did bang up job on a webinar for us recently on some more advanced scope features. I'm going to be basic. I'm going to give it the Homer Simpson treatment, because that can be me sometimes. And I suspect that some of us, even though there were some Sharpies 3 hours ago at the noon Eastern time, which was 9 o'clock my time here in this hotel on the West Coast. Please forgive me if I'm talking beneath you or over you, over your head, but there were some Sharpies that probably didn't need a whole lot of encouragement. They're good scope people, but if they learn one thing, it's worth that hour. So each and every one of you, thank you for tuning in to the Delphi Tech Tip Thursdays. I'm the senior instructor for Delphi, Dave Hobbs. I've been at this for a half a century, literally, since I was in my mid-teens as a technician. First, sweeping the floor as a kid, literally, grade school age, and my dad's auto electric shop. Whereas a lot of my counterparts, like fellow gearheads at Northwestern High School, were, they've already taken engines apart and pulled cylinder heads and stuff like that. That was all foreign to me. But I'd had alternators and starters and apart, and converted my '61 Chevy to run on HEI, electronic ignition, from point and condenser. I was the nerd wrench or gearhead of my day, and still am to some degree. But the scopes back in the '70s, the engine analyzers, and of course the lab scopes were just for electronic technicians, people that maybe fixed your TV or worked in some lab in some factory, like Delco Electronics, started in also Kokomo, Indiana, became Delphi, and I then eventually left my dad's shop thinking I'll come back and buy it, but I'll learn a whole bunch on the OE side first. And I got hooked on the OE stuff and on the high tech. And I've been here for 36 years. So a technician pretty much 2/3 of my life, over half a century, and 36 years of all the variations of Delphi, Delco Electronics, now PHINIA. We are PHI is the last three letters of the word Delphi, and NIA is New Beginning. So PHINIA is the parent organization. We're with Delco Remy. There's a great name. Dad being a big heavy duty rebuilder. We did a lot of rebuilding of alternators and starters. And like I said, on the scope world, it was the Sun machines, and we actually had one of about every model for decades, and I knew how to use it. But as we go forward and we get into lab scopes, there are numerous types, and I will show you some differences and talk about using common ground lab scopes and the voltage limitation of lab scopes to avoid the ultimate disaster, which is damaging or ruining your lab scope, which, again, I'm the Homer Simpson of high-tech stuff. The older I get, the worse it gets, all right? If you're over 60 like me, you understand, get checked for the dementia and the Alzheimer's, which I do. Don't have it, the grace of God, but those senior moments, definitely have those. And you can have those when you're young, and you have attention deficit disorder. You think you know what you're doing, and you get in there and you get frustrated, and you're trying to get a signal and you can't get one, and you got, geez, am I not back probing correctly? Is this sensor bad? Is this CAN bus got an issue? Only to find out it's your method and not the scope. So we'll give you some tech tips on that mini disasters, MINI type of disaster, which can be disastrous for your day and also for your self-esteem. Once you lose confidence, like I have a friend who's a master technician at a Central Indiana Chevy dealership, makes great money. I mean, this guy could run circles around me with diagnostics and productivity, makes great dough on flat rate, and he's not a scope fan. And he says, even the field engineers from GM come in and they struggle and they cuss and they go, that's not really worth messing with this scope, and they end up using a meter and the scan tool or throwing a part on it or a little combination of the above. So there's other folks like I just seen coming into the ATE conference. I was in the elevator going up and I seen outside through the little glass elevator, I see Gary Smith and Adam Robertson, a couple, I'll call them my heroes out there in the training business. Those guys and Gary, of course, being a ham radio operator, amateur radio specialist, I found those folks are oftentimes super geeks and they know how to use a scope and they know how to use advanced technologies and so forth. And I'll give you a little case study coming up on EMI RFI that has to do with things being way more complex sometimes we give it credit for. But back to my friend at the Chevy dealership, um, he also works at the college, Ivy Tech, in Kokomo, Indiana. There's like, I don't know, 15 Ivy Techs throughout the state of Indiana, where I'm from. I've been all over the world teaching engineers in places as far away as Singapore and Japan and China, Mexico, throughout North America, teaching them vehicle systems. Surprisingly enough, they're a little weak in that area. They know their little niches of electrical and mechanical engineering and chemical engineering. But when it comes to the big picture of the vehicle, they can sometimes be clueless. That shouldn't be a surprise to any of us, right? We know that's the case. So, or they wouldn't make things the way they do sometimes. It's not always about keeping it cheap. Sometimes it's about ignorance of how the big picture works and what you and I go through as technicians to fix these cars. So anyways, enough about me. Let's get right into the scope. I don't really have, like I said, a PowerPoint prepared. What I do have is hands-on virtual. And I did figure out how to get that working since the earlier session of Tech Tip Thursdays. So with no further ado, I'm going to share a screen and it's going to be a camera. Okay, there we go. So you should be seeing a full screen camera. Let me move some of this zoom controls out of the way there. There we go. So you see a meter on camera, just a pico. Let's see if I can get that adjusted just a hair. I said pico, I mean fluke 88.5 series. And it's sitting there kind of nervous, chattering around 11 volts. That's the output. You can see I'm piggybacked. I've got basically two sets of test leads. A pair of them are going over to this picoscope. So the smart lead, this B&C Plus on this newer picoscope of mine, I think it's the 4425A. I don't remember the numbers that well, but it's the latest and greatest. It comes with the EV kit. And by the way, back to my buddy from the Chevy dealership and other instructors at Ivy Tech and Kokomo, they're wanting a scope class because as advisory board member, I basically tell the department chair, this is where the industry's going. This is what you need for technicians, future technicians being trained at a 2-year university to be able to, get out there either in the independent world or the dealerships. And some dealers embrace the scope far more than others. General Motors has always lagged behind. They've used a picoscope years ago strictly as a vibration analyzer with special adapters. Instead of using volts and amp clamps and things like that, they use these vibration connections for their chassis ears for their uh, noise and vibration analysis. And I went to the local dealer. Gosh, this has been 10 years ago at least. and I saw a picoscope laying there on the service desk. And I said, "Oh, you guys have finally adapted the scopes. About time." He goes, "That's not a scope. That's a vibration analyzer." So I went out to my car and I got an amp clamp and I got a voltage probe, and we had a little short class on how to use a lab scope, the same lab scope that's used as the uh, vibration analyzer equipment for Pico at that time is also just a plain lab scope. So it's definitely easy enough to figure out, but sometimes hard to retain if you don't use that very often. If you work for a Toyota dealership or have worked for a Toyota or a few other dealerships in the past, they've grown reliant on using lab scopes. So if you're not a Gary Smith or Adam Robertson or gosh, Brandon Steckler, just name the scope gurus. Of course, who can't forget the late great Jim Lender with the Pico scope, Pico Guru 1, 2, and 3, Injector Guru 1, 2, and 3 series of classes. Some of my greatest regrets being invited to sit in and attend those for free and being too busy as a road warrior for Delphi to actually do it. So now Jim's gone, but there's plenty of people out there on the web that can drill down with different scopes, and of course at live conventions like I'm at now and on the little 1 hour we're doing today, you'll pick up some tips, maybe some advanced tips, and maybe some basic tips you've forgotten. All right, so what we're doing here is I'm proving that this little circuit board, this thing right here, my finger's touching, that guy is working. It's putting out some voltage. Now, how much is going into it? Well, that's easy enough to determine. Let me move my Fluke 88 leads from the output of that little ATEC board. ATEC makes a lot of great simulation equipment for the automotive training world, like community colleges and so forth. The Lincoln Techs and the Ivy Techs and those kind of places. So now there's the input from a regulated power supply sitting here on this desk in this hotel room in Seattle. 12.4, not digit rattle anymore, pretty much solid, regulated. It's a nice power supply I threw in a suitcase that I'll be using here. And I'll go back to the output. This is a pulse width modulation simulator board. Now, unlike a real PWM signal on a vehicle, let's say from a mass airflow sensor or something like that, this is going to have some interesting looking waveforms. But my point is, if you are seeing something on your scope screen, either it's not there, it's like, why don't I see anything? Or it looks crazy, go ahead and use your meter to back yourself up. Chances are, if you're like me, you've used the meter a whole lot more than you've used a DSO, a digital signal oscilloscope. So when you're seeing a signal jumping around, that's a clue that something is changing with that signal. Now, while we're talking about that meter, let me go ahead and move my finger over here to where it says Hertz, HZ. I'll hit it once, and it's a steady 18 Hertz. On this circuit board, I can actually change the frequency with this little rocker switch right here. Now it's 80 Hertz. And I can fine tune it with this little button right there. I can turn this little knob. Now it's about 82. Okay, let's get a solid number there if we can. We're just going to call that 82 Hertz. All right, now flip this switch the other way for a lower frequency, and it's about 18 Hertz. At 18 Hertz, how much is the duty cycle? About 11%. Okay, and then if I switch it from low to high, it keeps the same percentage duty cycle, but the frequency, it was 18 before, and let's go past that. There we go. One more time. Volts. 82 again. Okay, so 82 Hertz, and how much duty cycle? 11. Yep, 11% duty cycle. Flip the switch to a lower frequency, still about 11% duty cycle. And now we move over to frequency again. And now we are 18. So 82, now we're 18th, the lower frequency. So what does that look like on the scope? So once we've established something you're more comfortable with, and hopefully, I'm just hoping and praying that everybody online today, that you don't have a cheap meter like from Harbor Freight. Nothing against Harbor Freight. We got one in my hometown. And if I need something quick and fast, some cheap tool I don't plan on using to make a living, something a hobbyist or, do it yourselfer in my backyard, I'm there like everybody else. And my father, God bless, rest his soul, the master technician who had scopes and scanners and one of the first to have a digital meter, I think, in our town back when computer command control came out. Just using that acronym, CCC, C3, that really dates me, but that's how long it has been since you needed a digital meter. But when he got dementia, Alzheimer's, whatever, it's why politically it's hard for me to not to have animosity towards Joe Biden because it's like, hey, that's my dad, all right? You, when it's a loved one, you get even more sensitive. It's like, get off his back. You can't help it, all right? But it's frustrating. I realize that. But when you have a disease of cognizance issues, sometimes you forget some of those skills that were once very, very sharp. And he would get these coupons in the mail every week from Harbor Freight, and it was a free meter. So just come and get it, a $3 meter, literally $3 retail, and he would get the free one. And he did this for years. My mother, God rest her soul, she used to take him. She'd drive him. He got too old. He couldn't even drive himself. And he would go get those meters. And when he finally passed away and we had his funeral, every niece, nephew, kid, grandkid got, and there must have been 30 of us, we all got one of those meters. All right. So here's my hope for you. You're not using a cheap meter. You've got something like this Fluke 88.5 series. You got something that could read both AC, DC, current, diode check. And when you're looking at AC or DC, you can look at the frequency and the duty cycle. Those I would call the minimal requirements and a good set of leads and practice and lots of practice. Probably I'm speaking to the choir here. You all are there now, but maybe or maybe not. Are you absolute gurus? Are you Gary Smiths or Brandon Stecklers when it comes to the scope itself? So if you're a plugger like myself or a Homer Simpson occasionally, and you make a mistake, verify first off, are you trying to use too much voltage into that scope? The meter is good for 1,000 volts. That's why we harp on that particular meter. Meters like that, they're 1,000 volt category 3 rated. I'll be talking about that topic Sunday, Palm Sunday out here at ATE in Seattle at the Doubletree when we get into service and maintenance on hybrids, and we do our 4-hour classes, 3.5, 3 hours, whatever, 8 hours if you want us in your shop for a hands-on course. We're doing stuff straight with organizations as well as shop, shop groups and so forth. You don't have to necessarily go through some of our established customers that are very good supporters of our training, such as AutoZone, who's my sponsor for ATE through Delphi. They buy our parts and they support us with training, and others like WorldPack. I'll be at the FTX big mega conference coming up this August. So if you're coming out to our nation's capital in National Harbor, Maryland, which is, goodness, 10, 15 minutes from the DC Mall, where uh, the Washington Monument and the White House and the Capitol and everything is. Looking forward to seeing our nation's capital once again as we celebrate 250 years of independence in 2026. All right. So a month after the big hoopla of July 4th, I'll be out there. So wherever I am, and you see me doing a hybrid class, you always see the category 3,000 volt meter. Is the scope rated? is category 3,000 volts. Well, this one that I ruined, I'll hold this up to my little mini camera, okay? That one obviously wasn't because I let the smoke out of it and it popped. Picos should not do either one of these two things. They shouldn't make a pop sound when you hook them up, and they shouldn't smell. They shouldn't stink. Shouldn't pop and shouldn't stink. And I made one do it. This scope right here, this meter right here, this is the 4425A, I believe. That is the one that comes with the optional kit for EV stuff with some high voltage and high current inductive amp clamps and so forth. That's the kit I purchased to replace my old Pico, which I ruined. We're going to talk about how to avoid that. But the meter, it's hard to ruin one of those unless you got, I guess you're up in a bucket and you're hooked to, thousands of volts from a power line, which is not in our worldly duties here as auto techs. But certainly looking at 100 or 200 volts of AC or DC with electrified vehicles is not out of the question. Now, let's go ahead and go to stop sharing that screen. And we're going to share a different screen. So let's share the screen that's got the scope working right now. So I'll do that. There is, should be working good. Bingo. All right. Let's see if I can make this little toolbar go away. I'm not sure what you can and cannot see. There we go. So you notice it looks a little weird. I want to go ahead and hit the space bar. It's the thing about Picos I like. And I see some nice square waves, but I also see some really kooky looking artifacts. All right. I've just got the one channel hooked up. This is the Smart B&C Plus, but that's irrelevant. I mean, I can go over here and click on channel A, which I have running, and I can look at these various probes. And you notice one says probe right there, and I'm just using the regular B&C Plus. Now that's a convenience, the B&C Plus. If you've ever looked at the B&C on a normal scope, let's say you've got a snap-on or you've got an Autel scope, Autel scanner slash or snap-on scanner slash scope like a Modus or an Autel, and it's got the scope feature, as part of the scan tool. Typically you push the little bayonet. It's like a bayonet on the end of a rifle. You push it on and you twist it and it locks on. These new Picos with the B&C stands for British Naval Connector. When you just push it on, it snaps, and it's got a bunch of little, I think there's 6 little teeny tiny contacts besides the bayonet, the B&C type of connection that scopes have for each channel. And that detects not only what kind of probe you plugged in, but also if it's an inductive amp clamp. And it's not one of these like right down here in these pictures where you have to put a 9-volt battery in it. So it's self-powered. These are like this one here. These are powered by the scope itself. So it's a convenience, and it avoids things like drift to some degree when it comes to doing long-term time-based what do I want to call it? Current analysis. If you're using a milliamp clamp or a microamp clamp, even better yet, to look at parasitic current draw on a battery cable. They tend to drift over a course of time. They don't drift as bad if you have the self-powered B&C Plus like down here. But the other things in the way of probes, this is what we're going to talk about to avoid super disaster, killing your scope, which I did a few years ago. More on that, details of that story coming up. But something called a differential probe. And I'll show you one, what it looks like, what it does, and then something called an attenuator. So an attenuator you probably have seen. If you own a scope, it probably came with one. And there's a couple of flavors here, at least within the Pico options of this particular Pico scope, a 10-to-1 and a 20-to-1. So more on that later. Let's just go back to regular probe and go ahead and let us go live again with that pattern. I'm going to flip the switch on that circuit board like I showed you earlier And my meter's still hooked up. I'm going to read the meter while you're looking at the scope, and it's saying 18 hertz. Now I'm going to go fast with my little pulse width modulation duty cycle out of that little ATEC simulator board. And you can see we still got some spikes here and there. That's just a little artifact that's unique to this being a little circuit board slash signal generator, as opposed to, a real vehicle. If you were looking at a CAN bus, you're looking at a, square wave out of a different sensors that put out square waves. You might look at this and go, I got a problem every now and then. Let's freeze that pattern. Let's see, there's a spike and there's a spike and there's something funny looking there. In this case, we're not worried about that. It's not a real car with a real problem. It's just demonstration tool. But you can see what happens. Let's go live again. When I go from one frequency to the higher frequency to lower frequency. But my point was I was avoiding the usual, and I've been there and done it. And I'll bet you have too, especially if you maybe you're better with your scope now, but you remember when you first started, or maybe you're just starting now, or maybe you logged into this conference because you just got a scope, or you're thinking about buying a scope or buying a scan tool with a scope built into it, and you want to avoid these disasters. Well, one mini disaster is MINI, miniature, is just ruining your day and your confidence. Am I back probe correctly? Did my T-pin, catch up the back of the terminal crimp? Did my piercing probe break the wire, or did it just kind of pierce the insulation enough to get into the conductor of the wire? I'm not a big fan of the piercing probe, but I'm not a mobile tech that's trying to make bank, by getting into a shop and diagnosing a problem quickly. And even those mobile techs, I know that fabulous instructors, like guys like John Thornton, I look up to as my heroes. Um, those guys cover their tracks. They cover up they make sure they don't use too big a probe for piercing. And then, any hole they made in the insulation, they cover with clear fingernail polish or silicone or whatever. So they don't have a problem occur 6 months, a year from now on the Rust Belt because of something they did on the car. So anyways, back to what you do in your shop. If you probe and you're not seeing something on the scope, it's easy, unless you've got super confidence with your scope, to just consider, oh, geez, get frustrated like my friend from the Shiv dealership and go, they're not really worth it. That's why I'm doing a tutoring class to train the trainer for my own community college coming up here in a week or two when I get back home, so they can get more comfortable and more confident. When we're confident with the scanner, when we're confident with the meter, and when we're confident with our scope, then we can do our diagnostics with a lot less stress and a lot more accuracy, because confidence is really all it's about. Not overconfidence. That gets us in trouble too. And that's going to be leading up to a story that I'll tell you about how I fried my lab scope. All right. So if we want to take another look here at what we can do with this pattern, I want to click on this. And we talked about the probes, okay? We talked about attenuators and regular probes and the differential probes. And of course, on this newer Pico, it's got the smart probe you plug in. It knows what it has. Let's talk about DSP, digital signal processing, all right? If I turn it off, now we can see a lot of crap going on. So it's like a lot of things in life that once you get something working okay, and you've got things you can do on a computer, there's 18 different ways of fixing it. And it's definitely, you can't hurt anything. Is it Control Delete? Do I hit the power button as an example? Well, it's not really going to hurt anything doing it either way. Or you go to the menu and say shut down. There's a lot of different ways to do the same job. Okay. So the same thing with the scope. So how do I know that I should use DSP if your scope has that function, digital signal processing, basically a filtering? Turn it on, see what happens. All right. And what do I set it at? Well, we can change the frequency of what we're doing here until we see something that looks a little bit more like we want. Or maybe we're looking for a problem when it comes to interference and we don't want to have it on. We want to see the raw signal and maybe catch some problem. Now, if this was for example, if this was a wheel speed sensor of the active type where you turn the wheel, it makes a square wave, or crank or cam sensor that was to say 3-wire and it makes a nice square wave. And we've seen a pattern like this ATEC PWM simulator board for training purposes, then we would have an issue. We want to figure out why. Now, let me give you a little case study. It's a little bit humorous. It has to do with some job I was on, oh gosh, 20 years ago, probably. General Motors, I believe we were still part of them. We, as in Delphi, we were the Delco Electronics division of General Motors before they spun us off and created that company called Delphi that still exists today. And as a tech advisor and a hotline, guy, I worked a lot with technicians, check engine lights and things like that on the independent side. So the dealers would call us sometimes. They would get overflow at Chevy TAN, for example, their technical assistance network. And they'd call us. And also we would take some calls from independents, especially the local people. We sometimes would get good case studies and go to their shops and help them fix a car. Got this call one day. It was from somebody at Chevrolet, and they had a customer that they'd already sent a field engineer and they struck out. It was a Department of Natural Resources for the state of West Virginia. I'm going to go ahead and go off camera here. Let's see, where's my Zoom controls? There we go. Perfect. Stop share. I think I already stopped the share. There we go. Now we're just on regular camera. All right. So as I tell the story, I'm full screen. So as the state of West Virginia's Department of Natural Resources had a team of uh, DNR, game wardens that went out literally into the deep woods of West Virginia and tranquilized. They shot bears, black bears, with pellet rifles that had tranquilizers. And so they would knock the bears out. When they were good and sleepy, they would go over and actually tag their ear with a radio transponder. You think your job is a little bit difficult and maybe has some hazards? Try to be a bear tagger for in Appalachia. Definitely, you want your pickup truck, your company vehicle, to have good communications in case some bear doesn't like being tagged and you need some help. So this bear tagger had a truck that when you keyed the microphone on the two-way radio, they had to use low band, which back in that day was about 30 to 40 megahertz. So today low band would be 150, 160, high band would be 800, 900, megahertz, almost, gigahertz. These are frequencies. If you're not into two-way radios and business radios, this may all be, Greek to you. But being the son of a CB radio guy and friends with ham radio operators like Gary Smith, for example, the instructor that I think the world of. He's here this weekend at ATE. I mentioned earlier. Uh, I thought to myself, how's this guy get so smart? A lot of people I know who are technicians who also had this hobby of being an amateur radio operator and having to learn all the electronics to get the various licenses to be able to talk around the world on these 2-meter rigs and things like that. The 2 meters, it has a description of the waveform, how long it is, literally, of the radio signal. Those folks have to study up and have to have a passion for electronics. So, anyways, um, the DNR, I actually made a trip out to wherever it was in West Virginia, met with that particular garage when the technician working on the truck, met with their radio person, did not realize that if you touched the antenna whip, this was a long 102-inch whip for that low frequency that was necessary, low band radio for propagation of signals in hilly areas like mountains of West Virginia. And when the DNR guy would key the microphone, the transmission would downshift. I thought that was the weirdest thing ever. And of course, they did the usual, replace the TCM, program things, put, clean grounds really good, run extra grounds, yada, yada. And nothing was helping. And so I was there in the shop, and being a young hotline guy, didn't really know probably half as much as I know now. And still, what I don't know now is a mountain of information, of ignorance, and so forth. You probably feel the same way as these technologies keep increasing on vehicles, and you're struggling and doing things like 1 hour webinars like you're doing now. Anyway, so I held the antenna mast, not knowing what would happen when the radio specialist keyed the microphone. You get burnt, literally, and it's from the inside out. It hurt like heck. And so, I think I got blisters on my fingers, and uh, the radio tech, he knew what he was doing. He was a good old boy. He was just, you know, giving this young whippersnapper a lesson. He goes, "Did you hurt yourself?" I go, "Yeah." He goes, "You wasn't holding the mask while I was keying the microphone, was you?" Go, I go, "Yeah, I think I was." So I had a hard lesson, the school of hard knocks. I've had plenty of those in my 66 years on the planet and 50 years in this business. So I'm sure you have as well. Let me share the one oh, by the way, this on the case study of the DNR truck, the Chevy pickup. Went for a ride with the actual bear tagger. We went out in the woods. We're driving around, and I did a lot of stuff on the truck trying to fix it. Was puzzled, and we finally together came to a conclusion that not only did the radio not get static in it and lose its sensitivity for reception, but did not create a problem when you keyed the microphone to transmit, to talk to the base, um, if the air conditioner was off. So I then at this point came to a hypothesis, an educated guess, that the signal between the HVAC head, which is just simple discrete signal, it's either 0 or it's 12 volts, that is for AC request, that signal wire was the propagation mode. There was something about the wiring of the radio's power or grounds, or maybe the running of the coaxial cable under the dash, that was near enough to that harness between the HVAC head and the PCM that it was picking up that interference. And before I could even really get back to Delco Electronics of the day and get with my engineers and ask for, should I use a ferrite bead or some kind of a filter or a different kind of grounding method, something called bonding, where you add braided ground straps. It's for RF issues, not necessarily good for carrying current, but for getting rid of RF. That's called bonding. And before I could even get back, the bear tagger himself, the DNR officer, said, "Don't worry about it, Sonny. I figured out if I need to make a call or receive a call, I just turn the air conditioner off." So you talk about good old boys and gals from places like West Virginia, you can't beat it, all right? So that was a case study for that. Now, the next case study was actually a demonstration I did in a training class. And this is where I had the true disaster, not just being frustrated. How do I get a signal? If I lost my marbles when it comes to using my lab scope, and I just explained earlier, well, the solution is use a particular device you're good at and look at the same signal, see if you can see something. So use that fluke meter, for example, with frequency and duty cycle settings, so you can see both AC, DC, and frequency and duty cycle. If you're seeing something, then you should be seeing that same something on the lab scope. Then maybe you do need a little tweaking of the lab scope and get that signal to work. But if you're not seeing anything with a meter, it's probably your probing or the sensor itself or whatever it is in the vehicle that's to blame. So don't go beat yourself up, or the scope. You're not able to see it anywhere. Okay, that was our first part of our mission for this 1 hour webinar, was those miniature disasters. But the big disaster came at AVI Studios a few years ago with the picoscope I bought with my own money. And you guys are all buying stuff with your own money. If you're a shop owner, you're bearing the burden of, the cost of buying tools for your techs, or you're a technician and I need a scope, I need a scanner, whatever. You know what I'm talking about. This is, you love tools, you love to buy them, and then the bill comes due and it's like, oh my gosh, you got to explain it to your better half. And you wondered, am I buying too many tools? Am I making enough to pay for all the tools? Do I have enough tools? Did I really need to do the job? Well, my picoscope, I don't remember what part number this is. Let's go ahead and get the little rubber cover off. All right, and let's look at it here. This is a model 4423. Oh, there we go. Kind of hard to see, but it's model 4423. But what you can see, and this is what I did not know, uh, hard to get the focus. There we go. That's because I got the background blurred. I'm just going to read what's on here, okay? So what is on here? It says right down at the bottom with a little triangle, it says max 100 volts. Well, I'll have to defend myself, not being a total Homer Simpson. I'll call it a semi Homer Simpson. But in the past, I might have not paid attention to that, but I did. And I had one of those little attenuators, the little small ones, it's the B and C style. It was a 20-to-1. Attenuation means to drop it down. So whatever the comment you're making, if you attenuate it, you lessen it. I've learned this being married successfully for 33 years. You don't give your better half a compliment and then say the word but, blah, blah, blah. You think that's constructive criticism. All they heard was everything said after the word but, okay? Take it from me, all right? I love that outfit you're wearing, honey, but, and then they don't hear the rest of it, okay? So in this case, attenuation means to bring something down. Accentuation means to bring it up, okay? So whether that be in a conversation or amplifying a signal, same thing, all right? So attenuators, 20-to-1 or 10-to-1, they will drop the voltage down. And if you know that, you can set your scope up. And we seen that earlier, when I clicked on attenuator, there was, I think, a 200-to-1 and a 20-to-1 or a 10 and 20-to-1. I forget which it was. So I knew better. I knew that I was only rated for 100 volts, and I was going to be measuring an output of an inverter. Now, not the inverter that's used in a Prius or other electrified vehicle, but an inverter that you plug in the cigarette lighter. And I was basically showing the difference. We're going to go over to a cutaway Prius that ABI has in their studios and hook up and look at a real motor generator and how the inverter changes the AC, three-phase AC back into DC, and then how we make three-phase AC from the big battery pack and so forth. And that truly looks like three phases of signal of AC, sine wave. But the inverters you buy to plug in the cigarette lighter is what I had. So I had a 12-volt regulated power supply, just like I'm using today, and I plugged in a 150-watt little portable DC to AC inverter. And I had a nice looking, I'll call it triangular waveform. So this it's called a chopper circuit. So when that DC comes in from the 12-volt cigarette lighter plug, it's turned into single phase 120 volts of AC, but it's not a sinusoidal wave, it's not a perfect sine wave. It's a sawtooth pattern. If you've ever scoped it, you know what I'm talking about. So I scoped it and I looked at the frequency and I looked at the overall voltage with a meter and then with the scope, and everything looked hunky-dory. About 59.9 hertz, pretty close to 60 hertz. That's what a wall socket puts out. That's what you want from one of these inverters that's going to be powering up your laptop power supply, or maybe, a little compressor or whatever you have that's, 150 or 200 watts that you need some 120 volts of AC. It was 120 volts of AC. So then I had this epiphany. Well, that's awesome. Why not just go ahead and hook up to the power strip? I had a power strip on the bench right there on camera at ABI Studios. And the power strip, obviously, I knew it had 120 volts going to it. And I put the pico scope across the hot and the common, or the neutrals as sometimes called. And I heard a pop. And then I smelled something. And I knew that was disaster because it was my personal scope that I paid good money for. And it didn't work after that, and it still doesn't work. Now, remember, I use an attenuator, so I did not overwhelm it with too much voltage. So at that point in time, I like totally lost confidence. That was another disaster. Being an instructor, I'm supposed to be a subject matter expert, and I blew up my scope during a demonstration. So obviously, the director says, cut. All right. When I got home back from Fort Myers, Florida to Kokomo, Indiana, I went to doing an autopsy and figuring out what went wrong. Here's what went wrong. Besides the voltage issue, which I had corrected with an attenuator plugged into that particular channel, little B and C 20-to-1 attenuator, there was the issue that each of these channels had the same ground. So if you want to measure, let's say, 4 signals on a car, and sometimes that happens. That's why there's 8 channel scopes out there now. Because sometimes, 2 channels, 1 channel is not enough. You need several channels. I've got an 8 channel, uh, I forget the name, Hikoi or whatever, some Chinese brand that I need to get better at. But it's a scope, one of many scopes. I've got a little 1 channel AES Wave U scope that comes with all the accessories and the software set up already for automotive, which is a unique feature worth a little extra money that they get, like $400, whatever they cost now. It's a single 1 channel scope, but it's one of those scopes you need an attenuator and you would need something called a differential probe. This is where I killed this. The attenuator wasn't a problem. I used one. When you only need one ground for all 4 channels or 2 channels or 8 channels, that's a common ground. And when you have a common ground, that's an issue when you're dealing with AC line power, like power from the wall socket. And as we get into EVSV, electric vehicle supply equipment, that's the level 1 and the level 2 charge cables for plug-in hybrids and EVs. And that doesn't matter if it's the North American charge standard with the unique Tesla plug or the 5-pin and maybe 2 extra ones underneath it for DC direct fast charge that's on that Mach-E. So it's the J1772 style plug. It's all the same. It is high voltage, either 120 or 240, 60 hertz. It's like your wife's electric dryer or the wall sockets in your shop right now. You've got common, sometimes called neutral. You've got earth. And if it's a level 2 charge cable, charges twice as fast as 110 volt. That's level 1 charge cable. You'll have both a black wire, which if you ever replaced a wall socket, and I'm sure you all have, the black wire is the one that will bite you. It's the hot wire. And if you've got 240, like an electric range in your kitchen or your clothes dryer, you'll have a red hot wire as well, line 1 and line 2. Either way, when we work on electrified vehicles, we got to make sure we know what the heck we're doing so we don't have a lab scope disaster. So back to the common grounds. I only need one ground for all 4 channels. That's a no-no. You need to change that. And as I did my autopsy, I noticed there was resistance from a BNC, any of the 4 BNCs, and the USB. That's what connected to my laptop. So the USB to here had a connection and it had some resistance, but it wasn't like super high, like mega ohms. It was like a few hundred ohms. That was more than enough for what's called a ground loop issue. So I realized after I did some more research what went wrong. I had a ground loop because my laptop, which is what the picoscope was plugged into, had the same connection with earth ground that the scope itself had. And so that, not the high voltage, I had an attenuator to drop that down. The fact I had that loop. So how do you get by? How do you get around that? Like, oh, do you go out and buy the Pico? What model is this? I don't know. The 4425A, the one with the smart BNC connections, the BNC Plus stuff? Nah, you don't need to do that. If you have a scope you like, it's part of your scan tool. It's an Autel, it's a Snap-on, whatever, and it uses the same ground for all the channels. And let's say you look at its rating for voltage and you're good there, or you know to use an attenuator, still takes a chance of frying it if you're hooking into a breakout box like fluke cells. For those who are either going to be working on the power charging units, the level 1 and level 2 chargers, like maybe your shop has one. A lot of progressive shops are starting to buy them now for their customers and for their own use in the shop to diagnose and make sure they can charge that plug-in hybrid or that EV that comes in for service. All right. So if you're going to use the same scope you've been using that has that shared ground, you want to isolate that ground and that scope itself, actually. There's my BNC. Get that in the picture. That's the output. I'm sorry, that's from the scope. And then this goes to the actual connections that I'm going to be probing that's high voltage and potentially can cause damage to a scope that you're not aware if it has an isolated grounds or not. This is called a differential probe. As we looked at the options earlier of different probes there, that's getting annoying. I'm going to fix that real quick, hopefully. Video. Not going to blur the background anymore. There we go. You can see my hotel room. All right. But at least it's not going to go in and out of focus. So this is a Pico brand. There's other brands out there. And this says differential probe. And it's got an on-off switch right there. And then you can change it from either a 20-to-1 or a 200-to-1 attenuation. And so you'd want to then tell your scope what you just did, or in your head, realize you're going to be looking at a much smaller waveform, but it isolates the scope, the test device, from the device under test, the high voltage. So the high voltage world is not just for electricians anymore. It's for the auto electricians. And that's what we've all had to become as we've worked on electrified vehicles over the last several years. So how do you avoid that ultimate scope disaster? Well, experience is a great teacher, an expensive one, but I avoided it by buying the new Picoscope, which requires a ground for each of the individual channels. So I have to hook up a ground to these B and C plus connections that are the smart connections for channel A. I hook up a ground for channel A, channel B, and so forth and so on. All right. But if you measure between each of those B and C connections and each other, it's open. And you measure between the B and C ground connection at the newer Picoscopes and other scopes that are coming out. If you do find some that is an open circuit to the USB and to each other, then that's an isolated scope. Now you really have to worry about, am I under the voltage level? So if you want to see this in action, let's do it. I'm going to go off of this camera and I'm going to share the screen to the little closed circuit camera to wind this out. So I'm going to now unplug. Let's see here. There we go. From my circuit board. And I'm going to take a couple of these little pins here. Yellow is going to be my ground, and red's going to be my little adapter here, or blue, I should say. Oh, crap. Still got to use something else here. We'll get there. So now my picoscope is going to be connected to this very circuit board. I'm sorry. The shorter one is always the hot one. Here we go. Hot. Not that it'll matter with AC. And then neutral. Let's see if we get a signal. Now let's go back. I'm actually probing into right there. Here we go. Into that power strip with confidence, not overconfidence. So now I'm going to share. Let's see, screen. Okay, share, stop share. And let's do a new share. There we go. To the Pico. Here we go. Share. Now, we're too much voltage. Let's go ahead and do that. There we go. Now, does that look like a nice sine wave? And if we look at the voltage level, let's go ahead and just do a little, I lost my connection there. There we go. I really need some little spade connectors to get into these power strips. That's perfect. Hit the space bar, stop it. And if I look at my peak right there, peak voltage, and I use another ruler to come down to 0, how many volts do I have? 165 volts right there of peak power. That's 0 to the high as it gets. Now, if I use my calculator, there's a calculator up. It should be up on the screen. I hope it is. If it's not, I'll just tell you. If I multiply 165 times 0.707, and that's the magic number for what's called RMS, root mean squared. You know, some meters don't even do RMS. They're not true RMS meters. Scopes should be. We have about 116 volts. That's what I'm getting from this wall socket in this hotel in Seattle, Washington. And if I go off of that calculator and now I move from left to right, in fact, let's go ahead and change our time base. I have to make it live again. There we go. Freeze it. And let's change our time base. A couple little ruler patterns now. From the beginning of one of those sine waves, and another one over to the other one. And now I have 60 hertz. So we can see that with a meter, certainly, and we can see it with the scope. And if you know what you're doing with the scope, you can avoid the lab scope ultimate disaster, and that's blowing the scope up with line power. Something that you're going to be able to put off for a while, but not forever. I don't care if Drill Baby Drill is in office, okay? I'm not going to mention this tomorrow in my classes in Seattle. I don't think he's really popular out here, but Indiana, he's still popular, all right? So the pendulum of politics of transportation, as my dad taught me many years ago, all right, is always changing. So whoever's in power, it's always going to be that way. It's always going to be differences in what rolls in your shop. What you've got to be is flexible enough to maintain your wits and not have disasters in your confidence or with your equipment. Whether it's an old dump truck with a diesel engine or a brand new plug-in hybrid that comes in for repair, you know what you're doing and you're doing it without disaster. I'm Dave Hobbs, and I want to encourage you to contact me again. Here we go. I'm going to share that screen. Let's see, share. Come on. Perfect. Share. PowerPoint. Ba-ba-ding. There we go. There is my contact information I mentioned earlier. D.A. Hobbs at Phinia, P-H-I, last three letters of Delphi, NIA.com, D.A. Hobbs at Phinia.com, or here's my cell phone number, 765-480 4976. Appreciate all of you for logging in, attending Tech Tip Thursday today. And it is my pleasure to, if you contact me with, observations, questions, uh, complaints, it doesn't matter. I'm open to anything you want to talk about. Cell phone, obviously text me first because I get all kinds of weird calls from spammers and so forth, and say, hey, I was a tech. I was set in one of your classes and I've got this comment or the suggestion or a question on something in my world. And of course, email's the same way. All right. Anything? I'll open it up here to the. Let's see if we got anybody on chat saying anything. I don't see anything in chat. All right. With that, I'll go ahead and say thanks for watching. God bless, and read the directions as much as you can. Get training all you can to prevent any kind of disaster, including lab scope disasters. Thanks, folks. Talk to you next time.